Assalamualaikum, and we'll come back to our tutorial on the project of Gearbox. So today we'd like to see on the tutorial on how to generate or to how to create uh, the other end of our gearbox casing. And we have here in front of us is the front cover. To create our gearbox front cover, the other side of our gearbox casing, we need this front cover as our base of construction. So we start with creating or inserting in the front case um, construction tree. We need to insert a geometrical set, and here we name it as flange, for example. And then as the flange function is underlined here, we click on the surface of this flange of 3D model flange surface, and then we need to go to shape, generative shape design. Okay, we are already in the generative shape design function, so in here we need to extract a surface from the 3D solid surface. So we just click OK on it, and we have a extraction surface under the flange. So this underline is actually defined as the work object. So if we have underline under the part body construction tree here, means that anything that we did on the body afterwards will be saved under the tree here. So we need to create a new part in order to separate the part from each other, or to get organized work when you have a lot of uh, function like shown here. Okay, so after we have created the flange surface, we have to save our part model by pressing Ctrl S. We save the thing, and now we create a new part file by using start shape generative shape design, and the new part 2 I would like to name it as gearbox case. It's our second part of the gearbox, and in here we need to actually paste whatever we have done in our previous sketch. The surface, we would like to have this surface here. To go back to the previous part, or if it is not yet open, we have to go to file and open the file first, and then click on the flange. So this is the reason why we have two different parts, so that we can just select this and click copy or Ctrl C by using the keyboard, and go back to the generative shape design that we have. Click on the gearbox case parent construction tree, and then right click, we click on paste special and choose as a result, and then click OK. So now we have the result, the shape from our previous drawing. So this one can be closed or minimized. Right, from here we will have a very long construction tree afterwards. So in order to get our construction to be in a very orderly manner, we need to create 4 different set here. So we have geometrical set and ordered geometrical set. So we already have one flange and one main body. We have to click on the parent case. So we need to now name it as plane. Another one we need to have is the ordered geometrical set. So the first one will be Wireform, and then click on the gearbox case parent again, and the second one will be surface. Right. So under this surface, now we need to generate the sketch of this surface. So how to create that? We I'll first make sure that this is underlined on surface. So luckily my surface is the last part that I've created. So we just go click on boundary, sorry, yeah, boundary function, and we click on the line there and click OK. So now we need to create a sketch of this surface. So we need to go to Wireform and right mouse click and click on define in work object. And then we choose this boundary function and choose the surface edge and click OK. So we have the first line there. Um, we need to go to plane now. We create define it in work object, and now we have to create 4 planes. And the first plane will be 2 millimeter offset from the YZ plane, the initial YZ plane. And the basis of our projection surface will be this plane, YZ plane. So the second plane that need to be projected will be 13 millimeter, and the third one will be 120, and lastly 130. To make sure that we still recognize which plane is which, you can rename it by pressing alternate enter. While selecting the plane one, you can go to feature properties and name it as underscore 2 millimeter, and the same procedure goes for the plane 2 and plane 4 afterwards. So the next one will be 13 mm, this one will be 120 mm, and last one will be 130 mm. Okay, so in plane 1 we create a sketch. In this sketch we need to highlight the lines there and create 3D projection, and this 3D projection will be connected with our new lines, and this line should be the one that is used to create our foot for our gearbox. And we can also mirror it. Okay, so the length here should be defined as 10 millimeter, and the radius there should be about should be 2 millimeter, and do the same for the second one. So we can also mirror everything, mirror after we have created the radius actually. So that's okay. Can also do 145. It should be is already been created. Okay, so check on the analysis, sketch analysis, so everything is closed. So we have fine like that. Right, now we click on the plane tool. We create a sketch, and this sketch has a circle with a radius of 54, 54 radius. Then we need the dimension yet, so I can do it like this. So I want to have this bottom line. So I just create a 3D projection. So from here I can connect with these circles and should I do this? Alright, and then the same goes for this side. Okay. Alright, so these two are in junction with each other. Okay, and the same goes for this one. Right, so now what we need to do is delete the unwanted line. And the unwanted line is this half curve. Okay, okay. Forgot to create a radius there. So this one and these two must have a radius of 10 millimeter. Same goes for this side. Alright. Next, we want to project this sketch on the second plane. So sketch 2 on plane 2. Projection is under this one. Projection on plane 2. Click OK. Alright. Now we need to create a sketch on the plane 4. So click on sketching function, and then we need to create another circle with the radius of 40. Make sure that concentricity, and then it has the same line of connection like here. So project the 3D lines. Next, I like to create a line over down here. Then we can connect those lines. Next, the same goes for this side. And we can also do mirroring. You can just undo this or undo that process, and we do it like this. So the diameter here should be 2 millimeter. The radius here is 5 millimeter, and I can select all the lines now and mirror it on this line. Okay, so by using mirror, all the constraints is also mirrored to this side. Next, we need to trim the half circle. Oh, I haven't checked the sketch yet. So we click on the sketch analysis. So everything is closed, and that's fine for our sketch. So we have finished creating sketches on plane 1, 2 and 4, and what's left now is not that we sketch is sketch on plane 3. So in this plane 3 we need to sketch, we need to create um, elongated hole, the initial point at origin, and the length is 52. It's okay, and then the uh, thickness is 32. We can then measure it. This is measurement of 2. Okay, and these two lines must have a concentricity. Okay, um, what do usually is close. Okay, after we have finished the elongated holes, we go back to plane 1 and create another sketch on it. And the sketch is also another elongated hole, but now the length remains the same, 52, but the width is 45. And the length is 52. Um, okay, this two surfaces. Okay, so you have a lot of sketches now. That's why we must have orderly session 3 to reduce the confusion of your own sketch. In plane 4 we add another sketch of a circle. The circle has a radius of 4, and we have to make sure that this concentricity each other. So we can now hide uh, 2, 5, 6, 7 sketches, and we click on sketch 3 and sketch 4 to in order for us to create. So after we have sketch 3 and sketch 4, we can combine the sketches, or we make it as a basis of our projection. So we would like to create the surface plane. So after we have um, hide all the unwanted sketches yet, we go to surface and define work object. We select sketch 3, click blank, and the second curve will be the sketch 4. So the closing point, the first point here is showing the same direction. So the arrow on the first point is showing the same direction as the arrow of the second point. So if I click preview, you should have a surface like that, but since it is not the unwanted surface, so we have to refine our um, closing point so that our surface is in the desired shape that we want. We choose that point, and then second curve. So the first point, first curve. So curve, closing points, vertex one. So click on place, put it here, replace, put it over here. So both on the same in direction showing. Click preview. So we should eventually get this surface of our gearbox shape. Then click OK if there's no distortion of your surfaces. Okay, so after we have closed the blend the surfaces, the two sketches, you can then close the surface here, the opening surface of sketch 4. So by clicking on sketch 4, click on fill, click on OK. So we close the surface that we wanted now. So you can also click on project 1 and fill the surface as shown here. The surface here must be trimmed, trim, and to be trimmed is sketch 3. Elements to remove. So on the surface, we need to cut this open. The space that we have filled just now, we need to cut it open according to the contour of the sketch 3. So we need to go to split. Element to cut will be the fill tool, and the cutting element will be sketch 3. So we click on other side, so the transparent one will be the one that is being removed. So basically we have this surface here. So now we need to unhide or show sketch 2 and click on projection 1. We need to sketch 2 here. We need to project it, blend it with the sketch 2. And click OK. And then the sketch 2 should be filled. Alright. Show the sketch 6. Which is sketch 6. Then we need to split the fill 3 with the sketch 6. Click on other side. So we have that side, that surface to be cut off. Right. Next, enable sketch 6, sketch 5. So we have 5 and 6, and we need to do blend of 5 to 6. Click OK. So because it has the same form of wire, so you can just click OK without without giving a concern on the point of connection. Next, we need to contour of sketch 5. Out here is actually so if you want to look at it, so actually this is unclosed. So what we want to do is we need to close it. So it is in sketch 5. So click on fill, click OK. So if I hide the surface, you can see the surface already. So the surface is already closed. Control Z. Right. All the surfaces here, what we can do now is to um, combine them by using the function of join, and this join magic distance of 0.001. This join is named as the um, outer outer boundary of the gearbox. Alright, so we have join 1. So next we need to extrude uh, the surface from the sketch 7. So we need to show sketch 7, to extrude sketch 7, plane 3, direction of plane 3. So the dimension of limit 1 is 20, and the same goes for the dimension of the second limit, 20 millimeter. So click on preview, look at this, and click OK. I think I did the wrong measurement, so this sketch 2 must have diameter of 52, not radius of 52. Alright, so exit the sketch. Yep, so we have opening like that. Okay, alright, now we need to choose the join and the extrude surfaces. Actually, yeah, I think, okay, the one that we need to create is like this. Okay, by having these two, now we need to split and need to create a hollow there. So we don't need this surface actually anymore, so we need to do a trimming process. So we click trim and click on join, and then click the extrude surface. So look at here, the surface here is also transparent, and also this surface is transparent. And then we click OK on that, and we need to have this surface inside to be remain there. So again, on this string function, we need to click on other side until we get the surface that we uh, require just now. Surface model is finished. We can now go to we can now change our mode to part design. Define in work. Lastly, we click on this one. So there's this surface. So we need to click on close surface. Alright, click on trim, and then click close surface definition and click OK. So if I hide this, we actually have all the surfaces turned into a solid object. So you can close the surface. So the surface for my wireform can be closed now. Next, we need to surface function using thick surface. So we need to create this jack on this flange, but since the dimension is 9 millimeter length, so we need to project back this surface here to generator shape design template. Now I need to create an option. This will be on flange, and we need to create an offset of this flange for this one 7 millimeter forward, so that we have a 2 millimeter gap between each other, and then we can create a solid surface using this sketch. Okay, so this surface 1 can be hidden, including the boundary 2, so it's only 1. Right, so next we go back to mechanical design, part design, and by creating thick surface, by sticking, sorry, so we have to change it to part body, cancel, go back to part body, define work, click on this thick surface design, click on offset 1, and okay, and the first offset is 2 millimeter, second offset is 0, click on OK. So we have created the new flange, new flange for the front housing to be attached on with. Okay, by having all those things, we can now go to hide all curves, hide all lines, hide all sketches, and now we have our solid like this. Okay, next construction process will be to create a foot on this bottom part of the gearbox housing. So we need to select the XY plane and click on sketch to create um, contour like this. Alright, and then we have to measure the distance of the two of these lines. So it should be 70, and the two lines here must have a degree of 15 degree, and this line must be coincided surface there. And this line must be inside with each other. Alright, next what we need to do is 15 degrees, 70. Need to exit the sketch and then create a new sketch on the ZX plane. And in this sketch, we need to create a triangle. On this side, we need to create key, and this line with this horizontal is the dimension of 130, and the line the point there, this horizontal axis is 102, and this line is angle of 43, and then this line with this plane must be coincided with each other, and this line with this line must be coincided. And now we actually need to create to insert we need to insert a new body, and this body must include these two sketches. So go for the sketch 9. Right, so from these two sketches we need to create solid combine, sketch 2 and sketch 8. Sorry, should be now define a work object. So sketch 8 and sketch 9 we need to do a combination object. Sketch 8, sketch 9, and then click OK. So we created a model solid there. And lastly, this body must be removed by using Boolean operations. Remove, and you have the empty space over here. Alright, and then next we can fillet all the reducers there. 1, 2, 3, 4, 6. So click on fillet 5 mm. So all are filleted. Including the inner line. Mm. With this 5 mm. Alright, so select all the lines inside that box and fillet it to 5 mm radius. So we have finished creating our foot parts of the gearbox. Next, we need to create plane. You can also use, but this one is for uh, surfaces, so you can create plane on the YZ plane. And use this offset in 60 mm in positive X direction. And in this sketch, in this plane, we can start a sketch by creating a circle, and this circle has a dimension of 1.5 mm in diameter. And okay, so the position of this I think we created a constraint there, so we can create anywhere here, and the diameter is 10.5. It should be congruent or considering the eccentricity with this uh, bolt hole. Right, and then we can exit the sketch. From here we can now create a pocket with a depth of 51 mm. Okay, so we have a nice shape for our screw hole or bolt. Then on this surface we can create a bore hole with a diameter of 5 mm. And you can look at the sketch. This point is really in the center of this. Yes, and you can just exit it. Okay, and yeah, with the bore hole of 5 mm, you can exit the hole function. Um, Now you can open the part body. Um, yeah. Okay. So from the part body, we have this pocket and hole. You can select them together. Now we can project it by using user pattern. The position should be the position of the point there. Create a sketch on this plane, and by creating the same dimension of circles. Now we can create the so we have these two lines. So we can just click here and here. Right, and do this too. So this is 30. This with this vertical line is 20. And this in the vertical line is 75. Alright, next we create a point of intersection. Alright, next we convert all these lines into construction line and select all the intersection points and mirror it with these vertical lines. Next we exit the sketch and then we can select the hole, the pocket and the hole, and then click on here, click on sketch token, and then click OK. So this created the yeah, uniform boreholes for all the holes that we have created beforehand. After that, we need to create ribs on top of this flange. So we select the Z-X plane and then create lines up here to here. Then click these two, and they are coincided with each other. Next, the distance between these two points and horizontal line would be 61. The inclination angle between these two will be 11 degree. Okay. So we can just exit the sketch. Now we create select ribs, and from side the diameter will be 3. It now must be drafted. So click on the draft angle. The angle is 3. The faces to be drafted is the both sides, and the neutral element will be the top surface, and then click OK. Next we click on this right tangent fillet. The same goes for the faces. Lastly, the face to be removed is the top surface. Click OK. Have the ribs like that. Okay, so we need to create the ribs in these both sides. So what we need to do now is we select all the three elements of the ribs, then click on the circular pattern, And using the instance and unequal angular spacing, we click define 3 as the instances, and the angular spacing is 60. So now we select a reference angle to be x-axis. Next, because this is the distance can be defined here, we double click on this 45 and change to 240 degree. So that click OK, and then we have completed the extruding the ribs to the both surfaces. Now next we need to create a new plane, and this is plane should be 45 millimeter in from the XY plane, 45 negative, so it should be in the vertical direction. Next, this surface on this plane we need to do a sketching. So the sketch that we need to create will be okay, gearbox casing. So create the line like that, and then from here to this line should be coincided. Then this point with this horizontal axis must have a distance of 64, and the angle of this two lines should be 14 degree. Okay, so we exit the sketch and click on the definition. From side, it should be 3 millimeter. Neutral fiber is activated. Click OK. So this surface, and this surface. Ah, okay, okay, just like that, and then again, top surface. Okay, right. So we have the second um, ribs created by using the sketch. Next, we can just mirror the surface, the station here. So click, select all the three element again. Click on OK. So we need to click on the exact plane. Click OK. Alright. So we need to just exactly. Alright, so we need to create it manually for this. So click on this surface, and this surface. Element will be this surface. The plane direction is right, and then try tangent, this surface, this surface, and lastly is okay, top surface. Alright, okay. Next, we create the new plane on the YZ plane. offset at 137.5 in the positive x direction. Okay, this pin 7 into sketch on it. So we need four circles. Sketch with the sequence of the first sketch will be diameter 42, the second sketch will diameter 46, the third sketch will be the diameter of 52, and the last sketch will be the circle of diameter 62. So we exit the sketch, then we need to create by using the sketch 23 a multi-pad, and the direction of padding or extrusion is in the negative x direction. So this will be the first circle with the thickness of 0, and the second will be 7.5, the third will be 9, and the last one will be 60. So click on preview to get this circle with stacks. So 7.5, 9, and 60. Alright, so we can create chamfer on the flange edge here. So we click on chamfer and select this line. So the length is 7.5 degree 30. Alright, next we need to select the inner surface here and create a sketch. And this sketch is there are 3 circles. The center point should be coincided with the vertical lines of the main axis. So we have one first circle of 24 diameter. Next, wait before that, and the center point here and the one here must have a distance of 56 millimeter. And then based on the center point here, we create the second circles of 32 millimeter in diameter. And last circle would be 42 millimeter in diameter. Exit the sketch and we can create a multi-pad. Again, this is 0, this is 32.5, this one is 42.5. So click on preview and click OK. We need to create ribs that is supporting this ball bearing housing, and we need to select now the ZX plane and create a sketch. So from this side we create the line of so we need to create a line just above here, and then this line must have a distance till the outer edge at 80 millimeter, and the one here with the um, bottom line, diameter of 77, and the length is 10 millimeter. Okay, we need to exit the sketch. So we go to the ribs, click on from side, and the first thickness is 3 millimeter. Click OK. And then uh, so all the three faces, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and filleted at 1 millimeter. Okay. So we have these ribs. Okay, because we have an edge there, so we just select a stiffener, uh, complete crown, and this one. Right, then we have to manually, yeah, find the ribs, since you cannot project the chamfer. Fill it. Okay, so yep, you can this one can be done. So so what we need to do is just select this lines, all the singular line there. Oops. So we have to be careful by selecting it. One, two, 4. Okay, so we can continue for all the 5 ribs, and we will need to create another plane from the YZ plane as a reference point, and the distance is 5.5 in positive X direction. Right. Okay, So the sketch that we need to create on this plane is now we need to create circles, and this circle is 45.5 millimeter, and it should be concentrically um, ball bearing seat. Then we exit the sketch and we need to extrude a pad with the length of 15 millimeter, thick of 4 millimeter in um, next one. Right. Next, on the plane 8, again we need to sketch, change the size to here. We need to sketch where is this? Okay, so it was hidden. We need to do a sketch of a profile here, and this profile is actually so I project 3D line first. After that, click on this. Lastly, escape that, and another one line over here. Right. Then we need to measure this two. It has a horizontal, vertical, measure direction. So these two must have a distance of 25, and this line must be tangential with this circle, and the angle of this two should be the weight also. This outer line with this vertical line must have an angle of 20 degree. Alright. Next, we need to trim the lines into the sketch. Then we create a pad 5 millimeter in reverse direction. Click OK. Yep, should be sitting there. And then we need to create on the other side, so click on this pad tool and do this and select the ZX plane. So we have the supported there. Support. And next, we need to create um, groove this on this surface of solid, where we will locate the snap ring when we assemble the gear, the output gear or drive gear. And in that case, we need to select the ZX plane again, and we create a box. So this box has a dimension of 2 millimeter. And then the distance of this to the horizontal axis will be 22. And here, top line of the horizontal axis is 27.9. In this line, with the outer line here, the dimension of 24. Okay, so you see the sketch. Using this sketch, we create um, the nut around about the x-axis. Okay, so another groove that should be created is on uh, this, yeah, this bearing seat. So again, we select the ZX plane, sketch, and now we create another box somewhere here. The dimension is 1.8 millimeter. The bottom line with the horizontal axis is 53.75. The top, the horizontal axis is 7.75. Alright, and here to the end line we have a distance of 53.7. Okay, so using the sketch, and we do the groove about x-axis. Wait, this direction, this side. Okay, okay. So we need to do the groove. I made a mistake from these two, so this should be in the reverse x direction. The same goes for this one. So then our um, in that this group will be used to create the Yes, to go for the snap release. Okay, we need to create next. What we need to create is a plane 80 millimeter offset from the XY plane in negative X direction, negative Z direction, sorry. And this plane we need to sketch um, yeah, need to sketch the foot of the housing. Okay, we create a rectangle like that, and distance here will be 20 millimeter, and this one will be 30 millimeter. And this line um, coincidence each other, and this line also coincide with each other. So we exit the sketch, create a pad, click on more. So the first limit is 40, the second limit is minus 30, and the negative Z direction. Okay, so after we have created the first foot, we go back to the plane that we've created just now, and we need to draw a circle sketch on this side. Diameter is 16, and the position is good. So the first one is 10, and the second one is 15. Exit the sketch, then by using pocket with okay, depth of 25 in the Z direction, negative Z direction, create a ball hole, then click by clicking on this surface, create a pocket, so with the diameter of 9 millimeter up to next, and the position of the center point should be yes. So we have created our foot together with the ball. Now we need to select all these three, 1, 2, 3 parts, get 4, get equals 1, 2, 3. Then use this rectangular pattern, instance surfaces and spacing, instance and length. So instance 2, length 90, this is x, and then 135, this is y. This direction, so click OK. So now we need this, and this to be needed. And then can be transformed x, z. Right. Okay, so we have all 4 fits with ball holes altogether. So because this is a custom material, so we can refine all the edges. We can trim all the edges, fillet all the edges to 1 millimeter dimension. So you can select the lines that you need to do the edges and finish the drawing of this. Gearbox casing. Right, so you can finish selecting all the edges here. Here with the radius of 1 millimeter according to the instruction sheet. And after that, you can go to hide all the planes and sketching lines and so on, so that you have only the view of your box. And don't forget, this should also be chamfered, fillet. This also can be filleted, and all here, all the edges here can be filleted, except for this space where we have to use this as our surface for the combination or assembly with the front housing of the first case. Right. Last but not least, we can then apply material on the part body. So click on steel and click OK. So lastly, we save the file. So we save the file as part file, and you can then proceed with your assembly until you have all the parts finished and constructed. Thank you very much for your attention, and good luck.